Right, this question here from the 2018 exam, I think question B3. So it's one we're fairly used to. It gives our coordinates, what I call it, the in, up, down one. You go in, you go up, and you go down then. Okay? So in from the left, up from your XY, and down from your XY. So it says the image on the right shows a piece of roadside sculpture in the form of a steel hedgehog, which is located in the M11 in County Wexford. It comprised of a series of planar surfaces, each carefully angled to allow for the runoff of rainwater. Okay, so we can see them there, they're all angled. Rainwater obviously then runs down along with that. So figure B3 shows the planned elevation of four such intersecting surfaces. So planned elevation. The horizontal and vertical coordinates points A, B, C, D, E and G define the four planes are also given. So there's our coordinates over there. So our in, our up and our down measurements. So the first thing then, draw the given elevation and plan of the intersecting planes ABC and ABDE. Okay, so I'm going to go through that. You don't need to watch me doing that, you all know how to do it. So there I have my two planes, my ABC outlined in green and my ABDE outlined in yellow. So the first thing then it asks me to do is determine the hedral angle between the planes ABC and ABDE. So to determine the hedral angle, so the true angle between them. So we're going to find the line of intersection, we're going to find the true length of it, and then we're going to look along it. Okay, so first of all, establish the line of intersection, AB, and I'm just going to put that in red. Okay, so that now is my line of intersection in elevation, and here it is in plan. Okay, so I'm going to get the true length now of that line of intersection. So the first thing I need to do to get the true length of it is look 90 degrees to it from either view. So whether I'm going to get an auxiliary plan or an auxiliary elevation, the first step I need to do, because it's not a true length here or here, because it's not horizontal, or it's not a point view in any of those views there. So the first thing I'm going to do is find the true length of it. So the handiest way for me to work there is to take an auxiliary elevation, and then we'll be taking an auxiliary plan then after that. So an auxiliary elevation, so I'm going to draw an x1, y1 parallel to my line AB, and I'm going to project lines then at 90 degrees to that there. Okay, so I'm working 90 degrees to it. So I project up my points AB anyway. They're the 2 points on the line of intersection. And after that then, once I have my 2 points of line of intersection, I need one other point from each plane. So obviously point C from the green plane, and then I'm going to pick, we'll go point D from the yellow plane. Okay, so I'm going to take my heights now from my original XY and mark it from my new XY up. So that's my X1, Y1. Okay, so I can just take these straight off the question. So the height of A was 60. You can set your compass to the heights and you can mark them off if you want. The height of A was 60. The height of B was 35. The height of C was 100. And the height of D was 10. So just make sure you're marking it on the correct projection line. That's D, that was C, that was A, and that was B. Okay, so we have our line of intersection, which is our red line, which is our line AB. Then we have our green plane ABC. And we have our yellow plane ABDE. So I'm going to cut now point E because I don't need it for this, so I just went with A, B, and D. All we need is 3 points to define a plane. So what that view now gives me, it gives me here the true length of the line of intersection. Okay, so that was the line of intersection. And this here is the true length of the line of intersection. That auxiliary elevation there. So now I'm going to look down along that line of intersection and I'm going to see both planes as an edge. So we're just going to project everything looking down along that line of intersection. And we want to do our XY perpendicular to that. Okay, I'm cutting back slightly into that, but it's okay, it doesn't matter. So what I'm going to be doing now is that's my X2, Y2. Now it is better if your XY doesn't cut in through the last drawn, but look, it doesn't actually matter. It's not going to change the result from it here. So we're going to be taking our distances. So 1 step back, so 1, and then you step back into that one. So it's from our X1, Y1, back to our plan. Okay? So for this one, I'm going to set my compass to my distances and use that instead. Okay, so I'm going to get the furthest one first. So I'm going to get point D back to my X1, Y1. And I'm going to mark that for my X2, Y2 down along the line coming from D. So X2, Y2. So that's going to be D. I'm going to mark C next. On the line projected from C, from your X2, Y2, mark it off, and A and B. Now obviously A and B are going to be the same distance because our X1, Y1 was parallel to that AB in plan. And we're looking down along it. So the line AB, now I need to project that back to my X1, Y1. That's where I ran a little bit of bother when it was over. So again, from my X2, Y2, mark it off. So that is where AB ends up. Okay, so first of all, we'll go to our yellow one. So that's ABDE, so ABD. And then our green one, ABC. So you're now looking at an edge view there of both planes, and you should get 2 straight lines there. That's our line of intersection there. Okay, so that's just a point view of the line of intersection. And make sure you label that as your dihedral angle between whatever surfaces they're asking you for. Okay, so an arc there, middle your compass, line them in. So dihedral between ABC and ABDE. Okay, so always label up everything. So in the next part then they say draw the elevation and plan of point G. So I actually have that done already. And determine the distance between G and B. Then it says the opposite edges AE and GF of the surface AEGF are parallel. Complete the elevation and plan of the surfaces AEGF and ACG. So it's basically another little plane that they're putting into it there. Okay, so that's point G. So they want us to finish this off up here and also down here. So the first thing was locate point G. Okay, so I have G located and determine the distance then between points G and B. So basically determine that distance is, it's almost like find the true length of the line GB. Okay, so the first thing I'm going to do is I'm just going to lightly line up G to B in my plan and also in my elevation. Okay, so there's GB in elevation, there's GB in plan. They want us to find the distance between G and B. Find the distance between the points G and B. So I just need to find the true length of that line. There's a couple of ways of doing it, or a battlement is probably the handiest way of doing that there. Okay, so for that, I'm going to go up here in my plan. Now it will be over this view a little bit, it wouldn't matter, and then bring it up and bring out point B here. We could do it that way. We could swing this down in elevation. We could bring it down, which might be the way I'll do it. It might give me a bit more clearance, a bit more space down here. Okay, so I'm going to rotate that. I'm rotating GB there in my elevation. I'm going to go horizontally then out from B. And then I'm going to drop that down to my plan. Okay, so drop that point. So I've swung G down. And we're going to do the very same here then based on plan. We're going to bring it out. To meet that line we drop down. I'm going to call that G again. And that now basically is the true length of the line BG. Well, because it's now we made a level layer in elevation, or made a horizontal, and then we're looking straight down on top of that in plan. So that's going to be our true length. Of BG. So it tells us then after that that the opposite edges A, or is it AE and GF are parallel. These are truly parallel, they're parallel in both views. Okay, so looking at the question, that's what it is as well. So it tells us that they are parallel. So locate point F. So first of all, we'll go parallel for our one in plan. And we'll also go parallel for our one in elevation. We can see from the question that EF is vertical. So that's point F. So we can finish off that view. And G then goes back to A and it slides down behind ABC. Okay, and finish it off as well in our plan. So it's F in plan, just remove that bit there. And again, it goes back to A. G, back to A. Okay, and C as well also goes to G. And actually this little bit here should have been dotted ideally. Okay, so there's all the lines then put into all the various planes that are there. So after that, it says, so the opposite edges are there parallel. So complete the elevation and plan of the surfaces A, E, F, G, and ACG. Okay, so that's that done. That's grand. Now, after that then, it says determine the projections of a horizontal line drawn from C, which will touch the plane AEFG, which is that last plane that we're after drawing in there, okay? So a line drawn from, where is it? Drawn from C, and it'll touch this plane here, okay? So a line drawn from C and it hits that plane. Now it tells us, clue there, it's a horizontal line, that's important, drawn from C, at a point which is 55 millimeters from C. Okay, so we know it's a horizontal line basically, and it's going to be 50, strike that plane at 55 millimeters from C. So hence, and determine and indicate in degrees the true angle between this horizontal line and the vertical plane. So what we're going to do first is find our horizontal line, have it strike our plane, and then we'll determine our degrees that it makes with the vertical plane. Okay, so it's a horizontal line. Straight away I know horizontal line going through C, and it's going to be something like that there. Okay, hopefully you can see that. So it's a horizontal line, it's It's horizontal there, my elevation. We know it's 55 millimeters, it says it strikes our plane. Okay, at 55 from C is where our strikes our plane. Now, because it's horizontal here, we're going to see that line as a true length and plan. So what I'm going to do here is I'm just going to mark off a distance of 55. It's 55, yeah. I'm going to mark off a distance of 55, set my compass to that distance. Okay, so I'm happy with that. And from point C, okay, I'm going to strike an arc there like that. So somewhere along that arc, that line strikes that plane. So if we take this horizontal line, more or less has been a horizontal cut. Now C and F, right, they're going to be the same height. Okay, so that's slicing through that plane there at the back to slicing straight through it there. Okay, so we can now draw that in our plan. Okay, because we know it cuts it at point F, and we know it also cuts it at this point over here. So A, B, C, D, E, F, G. We're going to call this, I have a H. No, I'm going to call this then H. Okay, so I want to locate H in plan. It's on the line GA. That's my H in plan. And that essentially there, that is representing my horizontal cut that I have my elevation basically already, which is that horizontal line I drew from C. Okay? And I already swung an arc 55 millimeters from C. So where that cuts through that must be the location of where my line intersects with that plane A, E, F, G. Just project that back up to plan. Sorry, back up to elevation rather. So that's the location of where that line cuts through. G-H-I, I just call it I. Right, so point I is where that horizontal line cuts through the plane A, E, F, G. Okay? And the next one then, it asks me to determine and indicate in degrees the true angle between this horizontal line and the vertical plane. Okay, so that horizontal line, the vertical plane, we need to be looking at our vertical plane as an edge view to solve this. So basically, in what view do we see it as an edge view? We see it as an edge view in our plan already. Right, so this is our vertical plane in plan, which is our XY line. Okay, so our XY line is our vertical plane in plan. Okay, so as we're looking down at the object, that's the vertical plane, and all this underneath, that's our horizontal plane. Whereas in elevation, the XY line is an edge view of the horizontal plane, and all this up behind it is our vertical plane. Okay, now, because this is a horizontal line already, all we have to do is from C, so that's our line we're actually looking for. Okay, from C, we'll just extend this on. This is a true length. Okay, we're looking down flat at it, so we can just extend that on there like that, and that basically will give us our answer. Now it asks me to indicate in degrees, so I need to actually put the actual degree on it. And the answer I get for that is 50 to 53 degrees. So 53 degrees. So that's the actual angle that horizontal line that I've drawn here makes with my vertical plane. So when I extend it on, that's where it strikes my vertical plane. That's the angle it makes with the vertical plane.